I'm Norbert Preining from the arXiv team. Today I want to talk about the future of open science, or arXiv's role in making research accessible. I have talked on the first day of the conference a bit about TUG and TUG Live in arXiv. I will start with an introduction to what arXiv is. This is duplicated from the first talk, but for consistency and ease of viewing afterwards, I repeat this. So what is arXiv? arXiv is a website, arXiv.org, of course, with a lot of back-end services. What we do is we collect scientific preprints, some articles, papers, mostly in the categories of physics, mathematics, and computer science. Some other fields too, and it is the world's oldest and largest scientific preprint server. It was founded in 1991. At the moment we are probably already near 2.5 million articles, and the growth is accelerating. So we have a lot of papers. A few things why this is important. So examples of cutting-edge research have first been made available on arXiv, like large language models, OpenAI DeepMind, gravity wave research, Poincaré conjecture by Grigori Perelman. All of them were first published or only published at arXiv. And while a lot of arXiv papers, of course, end up in to get published in journals, some research fields actually keep arXiv the only publishing venue. And even more, why would an author, so when they are anyway publishing to a journal, would choose to upload to arXiv? It's to speed up the dissemination of the results and assert prior authorship. Both are very important in the current research world. So open, as I mentioned already, we are open, very open at arXiv. I want to pick out three things: open science, open source, and open access. Open science is that arXiv is completely open access, in the sense no paywall. Everyone has access to all articles, and above that, everyone has access to also to the sources of most articles. We have about 90% of our articles are from sources, so from TUG sources. Recently, by far the most are LaTeX, but some are plain TUG or MS TUG. Big thanks to Paul Ginsberg and his colleagues who started arXiv in the 90s, beginning of the 90s, and from the very beginning insisted that scientists submit their source code for the papers. So open source we use is TUG Live, of course, mostly TUG Live nowadays. For the old, we still have TTUG. I went into details in my first talk here. And LaTeXML, this is what we are talking about today, converting TUG files to HTML. We also write a few open source projects. There's AutoTUG, which is on CPAN. It's not actively maintained anymore. It is the system that drives our compilation as of now, but soon to be put to rest. We have a TUG2PDF converter Docker application based on TUG Live that will be available soon. That is what we use going forward. But today's topic is about open access. Open access in the sense to make research accessible. So there are the W3C guidelines about accessibility. And so, of course, as a funded agency or funded research group, we have made our websites already accessible according to the guidelines. But the problem is this really accessibility? If you're a blind researcher, can you actually use the resources on our website? And the problem is no. The handicapped people with disabilities, visible disabilities, they often can access our website, they can get it read out by screen readers, everything works, but at the end, at the moment, they end up with a PDF file. And PDF files are, as of now, as of the current status, not accessible. There is PDF 1.7 and UA1. Unfortunately, it really doesn't work. And So just to give you a few ideas, so this is a typical paper. I chose, I don't know, one from my logic area where I'm working on normally. And so it's a digital representation of a page, which often has a mismatch between paper geometry and screen layout. I mean, most of us don't have our screens up, so how to say, portrait mode. Zooming is often required. So if you zoom in, then you often have to do horizontal scrolling, so there's no reflowing in there, especially if you use mobiles. There is no responsive design, so adjustment to the screen size. There is a liquid mode by Adobe, but it's mobile only and it's proprietary, so it doesn't really help. But especially these improvements in layout, in reflow would help everyone. So not only people who have with handicaps, but everyone who just want to read a paper on their mobile maybe. So what are the PDF structure limitations? So if you look into a decompiled PDF file, it looks something like this. So I think that was actually one of my papers. So the problem is that the original structure, the high-level structure, so what is a title, what is a subtitle, what's the image, is practically lost. Everything is converted to typographic elements, like, okay, we use this font, this size, and just put these characters there. There is tagged PDF that introduced by Adobe, which aims to improve this situation so that the structure, the semantics can be recreated from the PDF file, but this is, first of all, most of the documents are not tagged, and there's very poor support for tagging PDF. There is a lot of work nowadays going on the LaTeX kernel side, and we are very happy to see this, but there is a long way to go still. Very simple. There is, and we had overwhelming answers from our researchers, blind researchers with whom we work, is that HTML is, as of now, the better solution. It has responsive design built in the language. It has, with most browsers, a dark mode. It has built-in language translations, which is also a kind of accessibility for people who are not extremely fluent in other languages. Built-in language translation helps. There are add-ins for all kinds of dyslexia or visually impaired. It also preserves the structure, sorry, the structure and the intent of the document. There is a rich marketplace for assistive technologies out there in the HTML space. Also, search engines work much better with HTML than PDF content. Also, this is changing slowly. And text harvesting is easier. So arXiv corpus is a huge source for LLM trainings. Yeah, so this is so. But the problem is we have all our scientific work is mostly available on PDF. There has been work done in converting PDF back to HTML. This is not trivial. As I said before, there are, many of the information is lost due to typographic setting. There has been work by the Allen Institute for AI on recreating this with artificial to recreate the structure, but it wasn't really successful. There is a working group also now within the PDF Association that works mostly on using tagged PDF to create HTML, which hopefully will be much better. So what we do now is we convert LaTeX to HTML. I mentioned this already, about 90% of arXiv's 2.4, 2.5 million papers that are submitted in TeX, mostly LaTeX, but and that helps, yeah. And using them to compile to HTML was an idea that started already, I think, many years ago, like 15 years ago, Dejan just recently mentioned. So there are, of course, some problems with LaTeX to HTML conversion. The TeX compiler produces also typographic information and structure is lost. So at the end, if you look, for example, at the output of DVI or the generated PDF is exactly like put a certain font size there, but the structure, the semantics is lost. So the TeX compiler is hard to use directly. So what happens is that LaTeX code is reinterpreted. So if it's a proper LaTeX with a good markup, then it can be reinterpreted into HTML. The problem, of course, there are a huge amount of hacks by authors, me included, that work around and making things more complicated. So in the very most simple case, think about if you have a section, it would be translated in most surroundings to an H1 or maybe H2 element in HTML. So that is a very easy. But that only works for a certain subset of the TeX language. But you know, like we have tens of thousands of LaTeX packages, and each one providing separate commands, separate environments, and practically all of them needs to be special case. So this is a huge amount of packages that somehow are in the backlog and need to be prepared for the conversion. Now, there are some partial solutions. I just mentioned three, LaTeXML by Bruce Miller and Ian Tineff from the NIST, then TeX for HyperTeX, created by Iran and now maintained by Michael. And there is LaTeX support for text PDF. This is, let's say, progressing nicely, but still early stage, I would say. We have tested at arXiv the LaTeXML and TeX for HyperTeX and some others. In the end, we settled somehow, mostly due to preliminary work, namely the arXiv, where the X is replaced by a 5 project. That was started many years ago by Michael Kohlhase and Dejan Ginev. And they converted the whole of arXiv corpus to, so not the whole, the one from LaTeX source files to HTML versions. This is still available. They had about 20% of failed conversion. Of course, visual glitches, but that is somehow to expect it, and there are permanent improvements. What is a bit the problem is reconverting old articles. There are a lot, and so with every improved version of LaTeXML, we would like to, well, just reconvert all the others, but this is quite costly. If we do this in the Google Cloud, we pay about 15 per document, and this is for the arXiv compass a few $10,000, which is not something we can easily throw out every time. So if it's incomplete and we have visual glitches, it's extremely helpful. I mean, the first, of course, the LaTeXML team has done an incredible work working through very popular packages and providing the necessary information for LaTeXML. But there's a long, long tail of less common packages that would be nice to be supported, but it's a huge problem to work through all of them. And then another problem, and that is hard to overcome, is when authors start to write macros and extension, because of course they don't provide HTML or XML representations of their macros. I think one of the most biggest problems is that TUG support is not complete. So the last time I gave this talk was actually there was nothing here, and now we have partial support. It is continuing well, but since it's one of the most popular packages, it's probably very important to get support for TUGs. There always remain some edge cases in LaTeX constructs that don't render quite right, version 2, and we have also the same failure rate as arXiv. But, and I think that is the most important thing, it's much better than having nothing. If we have papers with glitches in HTML rendered, they are still readable, and especially for screen readers. So something is better than nothing in the sense, okay, people can easily read out the HTML version, Might not that all formulas or all graphics are properly displayed, but at least compared to pure PDF without accessibility, the situation has greatly improved. So what is the rollout plan? It's already there. Every new paper nowadays is converted to HTML. So what arXiv did was great work, but it was of course less known than arXiv, so less access, less people downloading stuff using it. So we brought it in-house. It is now part of the arXiv normal setup. As I said, the submission process already creates an HTML version of the papers alongside the PDF. The PDF is the main output. We ask submitters also to review the HTML version, but it is not blocking. If the PDF is not properly produced or some problems with the PDF, this blocks the submission, but the HTML, we still, I mean, it might fail. There are many reasons it might fail. We also hope that authors review the HTML rendering and maybe get some feedback about improving the LaTeX source code, like adding alt text. Well, there are a lot of things that can be done to improve the HTML version. And also, we will see later on, we have all our users who look at HTML code as a QA tester, so we provide easy feedback button, and that actually gives a lot of reports on things to improve. So how does it look like in practice? So there's an abstract page on arXiv that gives the title, the author, the abstract, submission history, and on the side you can see here HTML experimental, so PDF, the text source, other formats, but well, HTML. And then if you select the HTML, you get the HTML page. You get on the top conversion warnings, so things that we cannot deal at the moment. Here, for example, Inconsolata is a package that is loaded, not supported. This is a third-party font. If you see this as like, okay, I mean, I don't need to see the paper in Inconsolata. I'm happy if I see it in the whatever font is selected. So we still have a better label there. And it's, as I mentioned also, it's only for new submissions at the moment, but we are planning to backfill this. Also, formulas and tables are supported, so conversion is displayed with MassJax and LaTeXML, and it also supports dark mode already, and there is also a big prominent report issue button that is also very much used. This is great to see because the LaTeXML team is taking the reports in consideration and improving regularly on this. So there are a lot of things that we still can do, we or the LaTeXML team. So first of all, the LaTeXML team is permanently working on improving the conversion process. We also think about the cost-effective way to periodically recompile the whole corpus, which is, well, not easy. There is work going on. So one part is that the conversion, that LaTeXML is written in Perl and takes quite some time to convert. There is some progress in rewriting it in Rust that would cut down conversion time like 2 orders. And of course, this is a reduction in costs. The other big part is that I mentioned this already, that the LaTeX core team is working very hard on getting PDF UI2, probably tagged PDFs, created by LaTeX. So this is something we definitely want to look into in the future from 2 points. First of all, we want to provide accessible UI2, accessible PDFs for those who have the PDFs. But it also can be used to generate the HTML output in the future. So that is something we will definitely look at in the future. Then there are things with what to do with charts and graphs. As I mentioned, if TIX is used, there is work going on. Charts or graphics is harder. There we often rely on so the authors to provide alt text or a description. Ways to allow users to access the data behind a graph. A graph is something very visual. How can we make this accessible. There are solutions to this that you can actually, for example, scroll on the X and Y side and get information about the values. Images and auto captions. Unfortunately, most authors don't provide good descriptions, alt text for the images, for those who cannot see the images. Would be a great idea to auto caption some of them, or graphs with an AI problem, or crowdsourcing. Many things that could be done in this direction. So to summarize, to give a bit of summary, so accessibility for scientific documents is very important. The feedback from the community after we enabled this HTML view was overwhelmingly positive. It was like, HTML is so much better than PDF, even when there are glitches at the moment. It's just, people are happy. It's not only blind or handicapped people, like many other people use HTML too. We are still very far from the last mile because there are so many packages that need support written. There's a huge package environment in Tech Live, so many packages that need to get support. We will have discussions about accessibility. We have an arXiv accessibility forum coming up soon. This is something where we discuss not only general how authors can improve things, a bit from the technical side, so all views come together there. And last but not least, I want to thank the many scientists with disabilities who have so generously shared their expertise and insights and feedback. That was really essential to what we have done in arXiv to make the website and the papers and everything better accessible. Also, this work was supported by the NSF grant. I also have to say, I mentioned this already, that most of the work presented here has been done before I joined arXiv, so it is a big thanks to the whole arXiv team. They're mostly their achievements I'm reporting here on. I will be here around for questions and answers, and at any time you can also reach out to me at my email. Thanks a lot.
Okay, thank you very much. I already see Norbert. Good evening to you. Do you hear us?
Hello.
Hello.
Yes, I hear you.
Okay, that's great. I'm sure there are questions. Boris, our proxy to the outer world.
Yes, a question from YouTube chat from Mikhail Sunquist. How long does it take a typical, say, 30 pages math article with a few graphics to convert with LaTeXML?
It's a good question, but as far as I remember, it's in the timing of minutes.
Minutes. Okay. And by the way, he added, thanks for very interesting talk.
Okay. Anyone else? I don't see. Oh.
The whole corpus has been attempted, I guess, several times.
Yes.
Have you minded to see what are the most often used packages and just how long that tail is? And
So of course.
Separately, for the 20% that fail, are those using a whole bunch of really strange ones so that there's not another 5 or 10 packages that, oh, that would get another 5% done? Thanks.
Yes, so of course, the LaTeXML team has statistics about which packages are used most often, and that is used for which of the style files or class files they are looking at. Of course, this is squeezed in some way because, I mean, there's a very specific type of articles we are getting at arXiv because we have math, computer science, physics. So there is a certain selection, of course. But yes, so that is the idea, that looking at the ones that gain the most advantage looking at them first. I don't have the lists. I can probably, it's nice, I can probably, if someone is interested, reach out, I can probably get them from the LaTeXML team. I also have my own for a few months. I did my own statistics about what is most used in the last half year or something. I don't have it here with me, but this information we have. And yeah, and this is also the way how the LaTeXML team looks at packages, at which package they should convert or write support for next. But there are so many packages that are not that common and maybe used only a few times. And I mean, they are in the long tail waiting.
Okay, thank you. Any more questions or comments? Okay, I don't see any in the moment. So thank you very much again, Norbert, for being present virtually at least. Okay, goodbye.